Let's try to convert the following parametric equation to an equation relating x and y. So we have x is sine of t, y equals cosine squared of t, and this curve is traced out over the interval for t between 0 and 2 pi. We know that cosine squared plus sine squared t is 1, so we know here that y equals 1 minus sine squared t, which is in fact 1 minus x squared. So every point on this curve lies on the graph of the curve y equals 1 minus x squared. The graph of the parametric equation is not necessarily all of the graph of the curve y equals 1 minus x squared, but the graph of the parametric equation is contained in the graph of y equals 1 minus x squared. Let's try to draw a few points on this interval for 0 less than or equal to t, which is less than or equal to 2 pi, to see exactly which part of the curve y equals 1 minus x squared is traced out by this parametric equation. So when t is equal to 0, then the initial point is the point 0, 1. And when t increases to pi over 2, the corresponding point on the curve is the point 1, 0 on the x-axis. Now when t is pi, the corresponding point on the parametric curve moves back to the initial point on the y-axis, the point 0, 1. And when t increases to 3 pi over 2, the corresponding point on our curve is the point minus 1, 0, again on the x-axis but to the left of the origin. And when t increases further to 2 pi, the corresponding point on the curve is back at the initial point again on the y-axis, the point 0, 1. So if we add some more points or join the dots here, we see that the particle oscillates back and forth between 1, 0 and minus 1, 0 along the graph of this curve y equals 1 minus x squared. And of course the full graph of the curve y equals 1 minus x squared is an upside down parabola which goes all the way to minus infinity. So certainly the graph of the parametric equation doesn't coincide with all of this curve. Now we can see the path of the parametric curve in Mathematica here. As t increases from 0 to pi over 2, the graph of the curve runs from this initial point at 0, 1 to the point 1, 0 on the x-axis. And then as t increases from pi over 2 to pi, the particle moves backwards along that same path from the point 1, 0 back to 0, 1. And then as t increases from pi to 3 pi over 2, the graph moves from the point 0, 1 on the y-axis to the point minus 1, 0 on the x-axis. As t increases from 3 pi over 2 to 2 pi, the path of the particle moves from minus 1, 0 back to the initial point at 0, 1 again. So we see this particle is oscillating back and forth along this portion of the graph of the function y equals 1 minus x squared.